Hello everyone, welcome again. So in this lecture, we will discuss two important topics in process planning and cost estimation, the make or buy decision and break-even analysis. So these concepts help manufacturing organizations make economically sound decisions regarding production, outsourcing and investment selection. Introduction to make or buy decision. So every manufacturing company eventually faces an important question: should a component be manufactured internally or purchased from an external supplier? So this is known as the make or buy decision. Although many manufacturers purchases their raw materials from suppliers, deciding whether to produce individual components internally or outsource them requires careful analysis. So why make or buy decisions are necessary? So this question should be ideally be evaluated for every component used in the product. So the decision directly affects the production cost, resource utilization, quality and overall profitability. Therefore, manufacturers must systematically compare internal production capabilities and supplier quotations. So the factors to be considered in make or buy decisions. When a supplier provides a quotation, the company must compare it with internal manufacturing cost. So internal cost include the material cost, direct labor cost, labor overhead, equipment fixed cost and other factors such as quality requirements and ideal machine costs. So these factors together determine whether manufacturing internally is economically viable. So let us see this with an example for a make or buy decision. Consider an example where a vendor offers a component for $8 per unit for 1000 units. Internal production costs $9 per unit. At first glance, buying from the vendor appears cheaper, right? The internal cost breakdown includes $2.25 for materials, $2 for direct labor, $3 for labor overhead and $1.75 for equipment fixed cost. Now we have to make a decision whether the component to be bought or made in the house. So however, decisions cannot be based solely on the supplier price. Fixed cost and overhead cost may continue even if the equipment becomes idle. If the machine remains unused after outsourcing, the company will still incur these expenses. Under such circumstances, buying externally may effectively cost 12.7 $12.7 per unit instead of $8. So by this reasoning, the decision to purchase might cost the company as much as 12.75 per unit. So on the other hand, if the ideal component can be reassigned to manufacture other profitable products, the outsourcing may be beneficial. Therefore, make or buy decisions must consider long-term strategic utilization of resources rather than only immediate cost comparisons. Coming to the introduction to break-even analysis. Break-even analysis is a financial tool used to determine the minimum production quantity required to recover all costs. It helps companies evaluate whether a new product, machine or process is economically feasible before making investments. Fixed and variable cost in break-even analysis. So break-even analysis is based on two categories of cost. Fixed costs remain constant regardless of production volume and include expenses such as rent, taxes and insurance and salaries. So variable costs change directly with production quantity and include materials and direct labor. So the total cost is therefore equal to fixed cost plus variable cost multiplied by production quantity. So fixed cost plus variable cost into fixed quantity, F plus VC into Q, where F is the fixed cost, VC is the variable cost and Q is the number of unit sold. Coming to the graphical representation of break-even analysis. So in the graphical method, fixed cost is represented by a horizontal line. Fixed cost is represented by a horizontal line. As production increases, the variable cost causes total cost to rise. So revenue starts at 0 and increases proportionally with sales. So the intersection of the total cost and the total revenue occurs represent the break-even point. Okay, the intersection point of these two curves, okay, the total cost and total revenue curves is called as a break-even point. So understanding the profit and loss regions in the break-even diagram. So if production remains below the break-even point, the company incurs losses because the cost exceeds revenue. Beyond the break-even point, revenue exceeds cost and profits are generated. Therefore, companies always aim to operate above the break-even quantity. So coming to the break-even quantity formula, the break-even quantity is obtained by equating the total cost and total revenue. Total cost and total revenue. The formula is break-even quantity equals to fixed cost divided by the difference between selling price and the variable cost per unit. So this formula is one of the most important equations in cost estimation and frequently appears in the examinations. So this is very important. F plus VC into Q, that is equal to SP into Q. Okay, so by solving this we get the following equations. Quantity at break even point or break even point quantity QBE is equal to F divided by SP minus FC. Okay, where F is the fixed cost, SP is the selling price per unit and VC is the variable cost per unit. Okay, so break even point in terms of sales values, the break even sales equal to fixed cost divided by 1 minus variable cost per unit divided by selling cost per unit. Next comes the contribution and contribution ratio. So contribution represents the amount each product unit contributes towards recovering fixed cost and generating profit. It is calculated by subtracting variable cost from selling price. So contribution ratio is obtained by dividing contribution by selling price. Similarly, the profit to volume ratio is calculated by dividing contribution by total sales. So this is the formula: contribution to the selling price minus variable cost, and contribution ratio is equal to contribution divided by selling price, and profit to volume ratio is equal to contribution divided by sales. Next, margin of safety. Margin of safety measures how much current sale exceeds the break-even sales level. A higher margin of safety indicates lower financial risk and higher profitability. Conversely, a low margin of safety indicates that the company is operating close to the loss region. So margin of safety in percentage is represented by sales minus sales at break-even point divided by sales into 100. So now let us see an example for a break-even point. Consider a factory with a fixed cost of 1,50,000 rupees, 1,50,000 rupees, and a variable cost of 10 rupees per unit and a selling price of 25 rupees per unit. Applying the formula, the break-even quantity becomes 10,000 units. The break-even quantity becomes 10,000 units. Therefore, the company must sell at least 10,000 units before earning any profit. Okay. At break-even point, total cost is equal to selling price. Okay, so always the selling price should be more than this one. Okay, so therefore the company must at least sell 10,000 units before earning a profit. So at break even point, the total cost is equal to the selling price, so there will be no loss, no gain. Above the break even point only the company will get profit. So if they sell more than 10,000 units, then the company will be profitable. This is an example for break even quantity. Okay, this is the formula for break even analysis. Okay, now we'll go to an example for a machine selection, break even analysis for a machine selection. So a component can be produced on either a capstan lathe or an automatic lathe. The different cost factors for the two machines are given below. Machine 1, fixed cost 500, variable cost rupees 2 per piece, and machine 2, fixed cost is rupees 1600, variable cost is 0.5 per piece. Assume that the cycle time for production of the component is same for both the machine. Which machine will you select for producing A 800 components and B 700 components. So break-even analysis can also be used to select between two machines. One machine may have lower fixed cost but higher operating cost, whereas another machine may have higher fixed cost but lower operating cost. By comparing total cost at different production volumes, the most economical machines can be selected. So in the capstan lathe and the automatic lathe example, the break-even point determines which machine should be used at different production quantities. So lower production quantities generally favors machines with lower fixed cost. You can see the lower production quantities generally favors machines with lower fixed cost, while higher production quantities favors machines with lower operating cost. So the result is N1 is equal to 800, machine 2 has to be selected, and N2 is equal to 700 and machine 1 is selected. Okay, next we will go with an example of break-even analysis for process selection. Similarly, break-even analysis can compare two manufacturing process. Okay, for example, the problem is given: the initial cost of the machine A is rupees 12,000 and the unit production cost of the machine is rupees 6 each. For the other machine B, the initial cost is 48,000 and the unit production cost is rupees 120 each. Do the break-even analysis, and with the available data, fixed cost of A and variable cost of A and fixed cost of B and variable cost of B is given. Okay, so the process with the lower total cost for the required production quantity is selected in this case. Okay, factors such as tooling cost, processing cost and production volume influences this decision. So at break-even cost, total cost of the machine A is equal to total cost of the machine B. So we know the formula for total cost, that is fixed cost plus variable cost. Variable cost is unit production cost into number of pieces. So equating these both at break-even point, the total cost of machine A will be equal to total cost of machine B, that is F plus Q into VA is equal to FB into Q into VB. From this we can calculate the Q value, that is 7,500 pieces. So if the production does not exceed 7,500 pieces, it is more economical to purchase machine A. For higher quantity production, the economic lies with the machine B. This is the inference for this problem, where we have to select the different machines. Okay, so for a given job, more than one manufacturing process may be used. The most economical process is that which gives the lowest total cost per unit. Okay, right, we will go with the next example with an aircraft component example. So the aircraft flap nose rib can be produced either by hydro press or by steel draw die. The following data is available for NT is equal to 500, PA is 8.40, PB is 14.8, TA is 6480 and TB is 1616. Okay, so what is TA, what is PA, PB? So TA is total cost, total tool cost for method A, and TB is the total tool cost for method B, and PA is the unit tool process cost for method A, and PB is the unit tool process cost for method B, and CA is the total unit cost for method A, and CB is the total unit cost for method B. These are the formulas. By equating the total cost of the two methods, okay, TA plus Q into PA is equal to TB plus Q into PB, from where we can find out the Q value. Okay, so like that we can calculate with unit cost, total unit cost fixed plus variable cost for method A, CA into NT is equal to TA plus PA into NT. From this we can calculate both CA and CB similarly, right? So we can apply those formulas in this aircraft example. Okay, the process with lower total cost for the required production quantity is selected. In this case, factors such as tooling cost, processing cost and production volume influences this decision. Okay, see, we have calculated the Q 760 pieces and CA as this value, okay, and CA as 21.36 and CB as 18.32. Okay, so the aircraft flap nose rib example compares hydro press and steel draw die methods. Using the given data, the break-even quantity and tooling cost for both methods can be determined. Such analyses are widely used in the aerospace and automotive and mass production industries. So with this example, we will stop our discussion here. So before that, to summarize, make or buy decisions help companies determine whether components should be manufactured internally or outsourced. Break-even analysis helps evaluate profitability and supports decision related to products, machines and manufacturing process. So both tools are essential for effective process planning and cost estimation. So thank you very much for your kind attention. In the next lecture, we will continue with additional concepts in process planning and cost estimation. Thank you very much.